going to demonstrate the SORBA SDE and how to configure and set up a machine learning model to autonomously relearn and auto-train. So in this example, we're going to use a pump as our asset, and the pump is going to be connected to a SORBA SDE, which is an on-prem software that collects data from the pump through some type of connection, whether it's an Ethernet IP, Profinet, Modbus, SCADA, OPC UA, whatever the connection is to capture that data. SORBA collects the data and then uses that data to train a machine learning model. And we call it a SORBOT or an agent. That SORBOT in real time will make predictions. And the outcome of that prediction can be anomaly detection, can be predicting a specific variable like power, efficiency, different types of things, as well as APC, where you can use that agent to not only predict, but also to make recommendations on how to improve it based on an objective or goal. There are other things like digital twins and forecasting as well. Today, we're going to focus specifically on anomaly detection. The anomaly detection model, usually call it clustering or an unsupervised learning. It takes data, tries to understand the data based on the clusters, and determines what is a baseline or normal behavior. And any abnormal behavior, the agent can then send an alert saying something is wrong, as well as what is the inputs or the variables that are impacting that anomaly. So let's jump in. And in terms of, as I mentioned, it's going to be able to detect alerts and abnormal behavior, where it can send that to the dashboard or to email or some type of enunciation that could alert someone to take a look at it. That agent, once it's trained, the auto learning feature allows you to automatically retrain that model. So that retraining can be based on several approaches. You can use that as strictly as a button for an operator to trigger that retraining. All he has to do is switch it on, and the retraining will automatically take data, retrain the machine learning model, and then decide whether the new agent is better than the current agent that is running in the system. And if that agent is better, it'll replace it, put it online, and then wait for the next trigger. That trigger can also be achieved through a schedule. So you can schedule that whatever you like based on what makes sense for the application every day, every week, every month. And then that trigger will do the same thing and retrain that model. Or a more practical approach can be detecting the drift of that prediction. So as that prediction drifts on that agent, if the error is large enough, it can trigger the retraining to improve the agent based on the actual prediction drift itself. So we're going to jump into the software, and we're going to show you how to set that up and make an autonomous machine learning agent. So let's go into my SORBA SDE. Let me cancel one of that. Okay, there we go. So in this SORBA SDE Edge, it is an on-prem software, runs on a computer or a compute module. In this particular example, the VFD, the asset we call VFD, has I/O. I created a bunch of I/O that is using a Profinet driver that talks to the Siemens drive. And the variables we defined is current, frequency, on and off status. That's not really useful for our particular agent. But power is, speed, temperature, torque, AC voltage, and DC voltage of the drive. The status is, and the actual set point of the speed is not really relevant, because in the actual speed variable, it'll show us what is the speed that the drive was commanded to run at. So after we define all that, we're going to collect that information. And currently this is set up to collect every 10 seconds. And we'll see that. I can show you on the dashboard here that we have. Let me zoom in there. So you can see that we're collecting temperature, current, frequency, power, torque, AC voltage, DC voltage, and then the speed set point is displayed, but we're not really using it. We're actually using the actual speed of the VFD currently. Again, this is the intent here, is to show you that in typical approach, you would need to have quite a bit of history in order to have a machine learning model or an agent provide a real or good prediction. But in some cases, you're just starting off, you may not have that historical data. So with this approach, you can use a very small range of data to initiate and create a machine learning agent, and then enable the auto learning that will, over time, get new knowledge, new information, and improve itself autonomously and automatically. And that's what we're going to show you today. So we're collecting some data. So the first thing we're going to do is we're going to go in and create a machine learning model. So I'm going to jump into my ML trainer. I'm going to create a data set, and I'm going to click on the new data set, give it a name. We'll call it VFD dataset 1.1. And we're going to pick the source. You can either import it from a CSV. Our hot data is what's being ingested and stored as a time series database. And the asset that is already set up here is the VFD. In that configuration, you also want to select the time range. So for demonstration, we're only going to pick a very small segment of data to show you how over time it will improve as the auto learning does its thing. So let's take, this is the last hour, so I'm going to narrow that down to, let's say, the last 10 minutes. So we'll call it, let me see here, let's do 3, and let's do 350. Okay, so the 350 is around, 10, 15 minutes of data, not a whole lot of data. So let's apply, pick our variables that we're going to use to train the model. I'm going to exclude all of them because there's probably a lot more tags than what we need, and I'm going to filter out the tags to only look at the IO tags. And then we're going to select the ones that we're going to use, which I mentioned. We're going to pick the current frequency, all the actual variables that give you different information about the motor. And again, that's always specific to the application. You want to, the feature engineering is where you want to select the appropriate inputs for your model to give you what your intent is to give you a good prediction. So things that make sense for the asset. And again, we're not using the speed set point, the status, or the on and off switch. Doesn't really apply to this or make sense in this case. So we're going to click save. Give it a few minutes to start learning, or I should say collect data. We're not learning yet. Let me, okay, so the data import completed. We'll just take a quick look at our data. We'll explore it. And Explore just gives you a visual visual illustration of the data, trending it, shows you all the ones that we've actually imported. How many rows we got in this currently. You can select all the rows or all of the records. So 210 rows of data, not a whole lot of data. Gives you different configurations of how you want to visualize that data. We're not going to go into that too much. I'm just going to jump right into, let's create a project. So we've got our data. It's about 15 minutes worth of data. We're going to create a project. And a project is really a collection of analysis that is tied directly to that data set. So we're going to give the project a name. We'll give it the same name. Click create project, and now we're ready to build some models and train some models. So click on the new analysis button, and in this case you want to be able to give it a name. We'll call it VFD Anomaly 1.1, and then the inputs, I'll use the default variables that we selected. We'll click next, and here's where you select the type of machine learning model that you want to train. As I mentioned, there's several. There's clustering, classification, regression, optimization, digital twins, and forecasting. So we're going to stick with the clustering. The clustering is going to use the algorithm to learn the baseline behavior of that motor or pump, and any abnormal conditions, it will provide an alert. There's two methods of picking the types of machine learning models. You can either, if you're a data scientist, you can go ahead and pick, and advanced settings, you can create and change the hyperparameters, or the SORBA proprietary auto ML can do all that work for you. So you don't really have to know anything about machine learning. You leave it on auto, you click next. The data set is only version 1, so we'll click that one and let the system train. It'll take just a few minutes. So the training completed, and you can see the status with the green checkbox means that it's done and there's no errors. We're going to visualize the results of that training. And in the Anomaly Detection tab, you will see, and it'll detect where the algorithm detected some abnormal conditions. So it looks like at the end of this tail of this data, there's starting to increase the anomaly. You can see the anomaly detection. So what it does, it creates boundaries around the normal behavior. And this one trend line illustrates how uniform or how normal is the data. In such a small segment, you're typically going to get pretty much normal, but when you're looking at a larger data, you'll see that there's probably going to be a lot more anomaly detection. So the point here is that depending on the score and how confident this model is, and let's take a look at the properties at the performance tab, at 0.118 on a clustering is a little better than halfway, about I would say 60-70% confidence. The range in an anomaly detection or clustering is usually -1 to 1. So it's a little better than half. So again, it's not the best, but it's definitely good enough to at least test it out. So we're going to do that right now. In addition to, one last thing is the tag ranking. This shows you which inputs was impacting this particular anomaly or the behavior of this model. And that is right now showing as the temperature as well as the DC voltage on the VFD drive. So now let's jump back into the SORBA workstation or workspace. And in real time, we're going to generate and create an agent, and we're going to put it online and allow the agent to predict in real time. So let's point to the folder called model instances for that asset. And we're going to create an instance of a model. And we'll give the model a name. We'll call it the same name. Anomaly 11, I believe I called it. And again, it could be pointing to the edge or it could be pointing to a cloud platform that you're pulling down models or machine learning models. Remember, this is an MLOps approach. So the machine learning trainer tracks, version controls all of your models that you're training. So this is sort of a directory of or library of all your machine learning models. So if I point to my project that I created, BFD DS11, and pick the analysis, which is the name of my anomaly detection model that I trained, and then the version. And this version code is just the serial number of that specific model itself. It pulls down the model, it pulls down all the hyperparameters, and it auto maps for you. If you scroll down to the IO section, you'll see that it found a matching tags or variables that match the actual model itself. So it tries to do that automatically for you. On the outputs, these are all the prediction variables. So you want to create other tags or variables that can display the actual variable, like the prediction, the anomaly score, the anomaly detection Boolean, the analog, the limits, and all the tag ranking, and so forth and so on. So this, you'll see there's an array of tags that you need to create. But if you don't want to go through the painstaking task of creating one by one, you just click the little suggestion box here. You scroll down because the inputs are good. We'll scroll down to the outputs, and then you click right here to create and suggest some tag names, and it'll automatically create those tags and map them for you to the model. It helps you save and rapidly create this without too much time. So once you've done that, you click Save, and then we'll select the Apply, and the Apply button will restart the system, put the agent in runtime mode, and then we'll start to predict in real time. Okay, so now after the Apply button has been pressed and the system has restarted, the SORBA SDE also creates a default dashboard for you to visualize the outputs of that agent. So this dashboard is just a default dashboard, and it displays all of the information for that agent, which is quite a bit of information. And you can always customize these dashboards and make it more simplified and just focus on the information that applies to you. What we'll focus on is the top left-hand corner, the input features. And here are all the variables that are the inputs of the machine learning model. And then the outputs is the anomaly score. And the anomaly score is a 0 to 100%, which indicates an anomaly or a normal condition. So if you remember the anomaly detection, this is the analog, and the algorithm predicted the high and low boundaries of that particular agent. So anything within those boundaries, within an 80% range of the high or low limit, will be considered normal. And that is transposed or transformed into a 0 to 100%. So anything that's in green is normal. Anything trailing up to yellow or red is anomaly or abnormal. And as indicates here, it looks like it's going up and down, fluctuating. So the model doesn't have a good sense of normal, even though the drive is running at a constant speed, or it's actually fluctuating or modulating like a sine wave up and down, just to give the model some variation and allow it to learn different behaviors. So as I said, the model is not really that great. The top right-hand corner, the anomaly score, is displayed as a gauge, so you can easily indicate, 100% is definitely a problem. And then the actual training score here as well shows you how the actual training prediction confidence. And as I mentioned, it's not the best. But for illustration, we're going to improve that by enabling the auto learning. And the tag ranking here is in real time. It's showing you what inputs are impacting. And this is updating every 10 seconds and the last 15 minutes of data. So we're going to try to improve that by enabling the auto learning. So let's jump back to the SORBA workspace. And inside the configuration of the agent, let me go into my edit mode. We're going to go to the auto learning section, and here you see it's blank. We're going to select a trigger. The trigger is another variable or tag that will be used to trigger the auto learning. That has to be a Boolean. So we've got a tag here we created called VFD sim retrain. And every time we enable that retrain tag, the system will then take a small section of data or whatever data history you define, automatically import that into the machine learning trainer, train the model, and then determine based on the score and the performance whether this is a better version of the model or worse. And so we set the actual span. So we're saying only take the last 10 minutes of the data, retrain it. And in this section here, you're going to tell it whether or not you want to update the model with a new agent, so keep the old agent separately, or just update the existing one. And then the one that's really important is this rollback option. So the rollback option is the internal decision point where the system will detect or decide whether or not to roll back. So if the new model is worse score than the current model, it'll roll back to the previous model. So you're always going to get the best model of the current existing agent. Okay, so let's set that, and we'll also set the retrain status. So I have another tag that tells me in what state or mode is the retraining process. Because in some cases, if you have a week's worth of data or a day or a month, that could take a little longer. So you always want to know, where is my retraining? What's the status of my retraining? Okay, so let's pick this tag called VFD sim retrain status. So let's click save. And again, we're going to hit apply settings and just wait a few seconds here until it finishes applying. Okay, so now we have our auto learning enabled, and we've assigned the two tags, the retraining trigger tag and then the retraining status tag. So what we're going to do in this example, we're going to manually trigger it. But again, you can set up that tag to automatically trigger it on a schedule basis, or I could use the prediction drift, and the prediction drift is part of the model agent dashboard. And that is this particular output of the model, which is mapped to another tag. You can use that prediction drift as a way also to trigger the retraining. So let's go back to my agent, and let's go to the data view. And in the data view is the ability you can modify that tag and enable it to 1. So let's trigger it, set it to 1. And as soon as that goes from a 0 to 1, the system will start the whole retraining process automatically. And you can go back to the dashboard, and you will see that as soon as it captures that, it'll go into processing mode. Give it a second, maybe set that little quicker updates instead of 10 seconds. Let's take a look at so it's in 1, so it should be displaying Yep, in process. Great. So it's currently now capturing that 10 minutes of data, and it's going to use and add another version to the data set, and it's going to use that new data to retrain the model. So if you go back to the machine learning, you can actually see this in real time. So let's refresh this. And you can see that the system automatically is now retraining a new version of that model. One of the advantages of SORBA and its ability not only to auto-learn and retrain automatically, autonomously, is its ability to self-manage and self-version as well. So every time that trigger or the auto-learning is triggered, the system automatically takes a record of that, makes another version, gives it a timestamp, a score. So at any point in time, you can go back and audit your history of all the models that you've retrained and their particular performance metrics. So this is another advantage. And now the system will determine, is this model better than the old model? And it'll make that determination. Let's go back to the dashboard. We can see it from the dashboard. So it says finished, and look at there. So the training score improved 0.4, which is much better than we had before. So the expected outcome is we should get a better better anomaly detection on the output. And in some cases it will be better, and in some cases you just may need to have more data. So again, depending on the behavior of that motor and the different types of knowledge and information it sees, it could make a better prediction. But the whole idea is to improve that score, that the expected outcome will be a better prediction. And again, you will see, going back to the trainer, if we look at that performance of that metric, we'll see that the performance score for that version of the model is 0.4035, which matches the actual model now updated with this new agent. In addition to not only the machine learning model version, it also keeps track of the data sets. So if you scroll into the data sets, remember we had to manually import the data, then select the data set to train the model. In this case, it automatically created a new version of that data, which represents that the last 10 minutes of data. So it versions all of the data sets as well as the machine learning models. And that's a really cool feature. So let's go back to our dashboard. Okay, so you can see that it's now training. It still takes about a few minutes in order for the model to get another image of that information. Depending on the window size of the agent, it may take a little more, a little less time. So what we're going to do now is we're going to retrain it one more time. So I'm going to set that to 0 because it needs a 0 to 1 transition. And I'm hoping here is that it will be not as good, because in some cases, if you're retraining and it triggers, as I mentioned, you may have a worse model score than the previous model, and you'll see that the system will roll back automatically. So I'm going to reset that to 1 again. Let's see if this will work. Okay, so we'll give it a second, and it should go into in process mode. There we go. So we'll go back to the dashboard, and you'll see that it is in process of retraining again, capturing the last 10 minutes. Now, I didn't wait 10 minutes, so a lot of the data that it's retraining is probably going to be the same data already collected. Probably, could have waited a little longer for that, but for the sake of the demonstration, we're going to show you that the ability for the system to retrain and make a decision on which model is better or worse. Okay, so the retraining has been completed. Now let's take a look at the actual the best score gauge. You can see that it hasn't changed. So my assumption is that the model probably reverted back to the same existing model. Well, let's take a look at the machine learning trainer. Let's take a look at the analysis window inside the training project. You'll see now there's a third agent with the new version. So the first model was dataset 1.0.0. The second was 1.0.0 and version 1.0.1. The third agent is all 3 versions of the data set. So it's taken into account all of the data in that particular asset. So let's take a look at the performance score. And there you go. So it looks like the actual score of 0.332 is not as good as the score of the previous agent. Let me go back to the model. Let's go back to the second iteration of that model, and let's take a look at that score. And this is probably the 0.4035 or 0.404. So that's what it did. So it made a decision that the score of the new model was not as good, so it reverted back to the old model. And that's it. That is the demonstration. Again, reach out to us if you have any questions. Thank you. Bye-bye.